Okay, ladies and gentlemen, good evening. I think we are right on time. Since people are also web streaming the event, we should start on time and finish on time. And we have just an hour for this session. My name is Julien Guerrier. I'm the director of the SME agency of the European Union, EASME. EASME is implementing a number of programs for the Commission, in particular Horizon 2020, dedicated to the environment and natural resources. In 2020 in particular, we are launching a call for proposals on low-carbon, competitive and circular industries. This call is already open, so those of you who are interested can apply. It is really my pleasure to welcome you for this session today. We are going to talk about industry for a zero-waste economy. Together, we are cleaner. The focus today is really to discuss how research and innovation can effectively support industrial symbiosis, how it can help the EU achieve its ambitions in terms of circular economy, in terms of carbon neutrality. This session is also, as you heard from Jean-Éric Paquet a bit earlier today at the opening, what we call a co-design session for our strategic planning for Horizon Europe. So our objective today is to listen to you, of course, panelists, but also to listen to all of you and gather your comments, your suggestions, your doubts. We have a team of people from the DG and from the agency here who will frantically note down everything you have to say and to advise us to do. And this will be reported to the closing session and then in writing to the team that is doing the strategic planning for Horizon Europe. So the objective is really that this is not just a conference, this is not just a forum, this is not just a panel discussion, it's a co-creation session for Horizon Europe's strategic plan, and in particular for the cluster number 4, which will deal with digital, space and industry. This is particularly important to us, not only as a method to get the whole research and innovation community in Europe to cooperate and to co-design the support schemes at European level, but also because, as you may know, we have a new commission coming in, and the priorities of the new president-elect, Mrs. von der Leyen, are very clear. It's first and foremost the European Green Deal. And it's also an economy that works for all people and a Europe fit for the digital age. So what we are going to talk about today on industrial symbiosis is at the heart of those priorities. Industrial symbiosis is very important to us. It's getting even more importance in the current political context. But it's not something we are discovering just today. We have set long-term ambitions for climate neutrality of Europe by 2050, and this will require industrial transformation. Industry has the means to contribute greatly to that objective. We have adopted already in 2015 an action plan for circular economy. What we want is to reduce waste, it's to improve resource efficiency, it's to retain the value of materials in the economy as long as possible. But today, when we look at the state of play, European industry is facing quite a number of difficulties. The main one, I would say, is that it's still very dependent on resources, on energy, on materials, on water, and we do not have yet, at our industry level, a secure and reliable access to all these raw materials. Industrial symbiosis comes in here because it offers to us a real opportunity to improve the efficiency of our industry, to improve its competitiveness, and of course to contribute to our mid and long-term climate and environmental objectives. If we look, for instance, at the process industries in Europe, they are central to our economy. They represent roughly 20% of the jobs in Europe, 20% of the turnover of European industry in total. But at the same time, they are also among the most energy-intensive ones. They put a lot of pressure on natural resources. This, in turn, creates pressure on our water resources, on biodiversity, and we see the consequences already today. Europe is at the forefront. We have been reducing our emissions quite steadily in the past few years, but we need to step it up one level or several levels to get to become really circular and climate neutral. So, interestingly also, I was hinting at it a bit earlier, industrial symbiosis is not a completely new idea and concept. We will have the presentation later on of the experience at Kalundborg in Denmark. The Kalundborg symbiosis project started in the 70s. So already there, we started industrial symbiosis. We have also a number of projects under Horizon 2020 that have fostered and supported industrial symbiosis. And maybe here, to get a bit more concrete, I should give you one or two examples. And the first one I wanted to bring to your attention is called FISAC. It's an example in the construction and demolition value chain. And FISAC has demonstrated how we can reuse industrial waste from the steel, the glass, the ceramic industry as a raw material for the production of construction materials. It has reduced the carbon footprint of cement production by more than 10%. It's also developing now a digital decision-making tool which connects with the different stakeholders along the whole value chain, from construction to demolition. It identifies along the whole chain those symbiotic opportunities for them to happen in real life. Those cost reductions are real, they are tangible, they have happened, and if replicated at the scale of Europe and the whole sector, they could have a huge impact on recycling and waste. Maybe I will skip my second example in the interest of time. But this FISAC example is just one among many that we have financed so far in 2014-2018. So for the first 5 years of Horizon 2020, we have invested more than €500 million in 88 projects, which involve more than 1,000 different organizations and partners. 27%, interestingly, are SMEs. You will hear in the panel discussion about the achievements, the potential, and some challenges of these projects. Dr. Zummer, in particular, will be the first speaker today, and will come to that. That's to underline that funding programs like Horizon can have a real impact. What we want to demonstrate today is that technology trends related to industrial symbiosis are key to the success of our progress, that their impact on circular economy and climate is important, and we will give you a few hints about the funding priorities under Horizon Europe and hopefully hear from you about that. I want to present to you Carmine here, who will stand up. He will be the colleague in DGRTD who will note down all your suggestions. He will also take note of all the questions that you can ask through Slido. I hope you have your mobile phones and you are wired and can ask the questions. They will come to us and we will discuss them. But first, we will have the panel of practitioners here, sharing with us their insights on the achievements, the potentials, the challenges in this area. We will have Dr. Klaus Zummer sitting there at the very far left. He's an expert. He's a former president of Aspire, the European association managing the Spire Public-Private Partnership. He's also the former chairperson of the European Technology Platform for Sustainable Chemistry, and he will make a short presentation to you. And then we move to our panelists with, in the order they are seated, Rachel Lombardi, who is Director of Business Development from International Synergies Limited in the UK, Pierre Joris, who is the current president of Aspire, I've just presented. Then we have Lisbeth Randers, who will talk to us about Kalundborg, this Danish symbiotic project that started already quite some time ago. And Valentina Colla, who is from the Research Center Institute of Communication, Information and Perception Technologies at the Scuola Superiore Sant'Anna in Italy. We will have about half an hour to get the input from you, from the room, through Slido, and to discuss them. So, without any further delay, I would like actually to call our first speaker today, Dr. Klaus Zummer, who will present to us the findings of his study on Horizon 2020 projects on industrial symbiosis. Thank you in advance for your overview of the current state of play on industrial symbiosis projects, and we look forward to hearing also about your opinion and your recommendations.
Well, thank you, Julien. Ladies and gentlemen, I will do what I was told, namely to report on a study. And this study is on a cluster of projects on industrial symbiosis, funded by the Directorate Prosperity in DG R&I. And why did the European Commission commission this study? It was clear from the onset that industrial symbiosis can be an important contributor to achieving overarching policy goals. And I think Julien mentioned them already, the circular economy as a primary target, and then secondly, obviously, the climate crisis that is one important driver for many activities that are currently funded. And you already mentioned that the newly elected president of the Commission has obviously upped the ante here. The reduction in CO2 emissions or greenhouse gas emissions will go from 40 to 50% at least until 2030. So it is really a call to action for all of us, and industrial symbiosis can play a part in that game, and that's why we did a study. The purpose is obviously to review these projects, but then also get the insights from the practitioners who are conducting the projects, but who are also active in some of the sites, and then develop some recommendations, so to say, from the industrial symbiosis community for the industrial symbiosis community, and also policy recommendations for the Commission. So what was the approach? The approach was we looked at all projects funded by DG R&I, in this particular case, the Directorate Prosperity. And we had about 28 projects to the tune of about 174 million euros over multiple years, obviously. And all the projects, beyond obviously studying literature, but all the projects were asked to answer a questionnaire and to participate in a workshop. And then in that workshop, we actually worked a lot on increasing the input that was already given in the questionnaire, and that's what I'm going to try to summarize. In addition, 2 established industrial symbiosis sites were visited, and that was Kalundborg, so we'll hear some more about that later, and Smart Delta Resources at the Rhine Delta. And they also participated in the questionnaire and in the workshop, so their input is being used. And before we focused on technologies, which is obviously at the heart of a study for DG R&I, we looked at the process of how industrial symbiosis can be established. And out of this, we firmly believe that understanding the process, how industrial symbiosis can be started, is really crucially important. Awareness of the potential for the potential partners is something that is lacking a lot. So we must focus on that. The willingness to enter into discussions which are open between competitive industrial partners is something that's not trivial. And this open dialogue is needed. There are a lot of barriers that need to be overcome, and the facilitation will be one important aspect to make sure that these concepts of industrial symbiosis can be established, and I'm sure Rachel will talk to that a little more. Inspired by the concept of the...
It's on the screen, so they can see
okay,
it. It's up there.
Okay, so I'm the only one who can't see.
It's down there, down.
Okay, so inspired by the, thank you, by the concept of technology readiness level, we thought that it might be useful to have something like a symbiosis readiness level. And what that basically means is, from what we saw, it is not just one dimension for which you have to fulfill certain conditions to advance. And we think that technology obviously needs to be available, the business case needs to be established, the ecological aspects need to be analyzed, and the management of the symbiosis needs to be set up in a proper way. So the proposal is to use this as a tool for realistically assessing how far a symbiosis is advanced. It's a proposal, it's a concept, and it will be discussed in the upcoming validation workshop in early November. Although we had 28 EU-funded projects and 2 industrial symbiosis sites who were included in the study, the overall market potential and the value added is not so easy to identify. And that's because numbers are not necessarily published, and it's not so easy to get those. But there are some good indications for that. For example, the ShareBox project is predicting that savings of 14 million euros per year and sales of about 50 million euros per year can be created through industrial symbiosis projects. And in another report commissioned by DG GROW, there was an analysis attempted for the generation of value and the market potential there for transaction involving secondary materials was very high in the billions, between 7 and 13. So to put the benefit of industrial symbiosis into perspective, I think it's good to look at least at some numbers on the CO2 equivalent emissions. And all of Europe emits 4.5 billion tons of CO2 equivalent. And industrial processes are about 8% of that, so that's 360 million tons. And NISP, that's National Industrial Symbiosis Program, joint initiative of international synergies and the UK government, report savings of about 42 million tons of CO2 equivalent in the period of time from 2005 to 2013. And in another report, building on the NISP numbers, the overall potential, if industrial symbiosis was used universally and broadly, is about 45 million tons of CO2 equivalent per year as savings. And that would be about 10% of everything that is emitted through processes in industry and product use. So I know this is, numbers that have error bars, but the potential for industrial symbiosis to have a significant impact on climate neutrality is evidently huge, and we need to make sure that the projects and the implementations really happen. Investments are needed from the private side to establish these projects and technologies, but also from the public side, because as always, this valley of death of technologies needed for such implementation needs to be bridged. And it's always good to have funding, for example, from the European Commission for R&I projects, so that it is easier to get these investments done and then ultimately come to implementations. The technologies that we looked at are summarized in the report in more detail, so I can't do this here now. But when you look at the areas that are addressed currently and the areas that are named when you ask which technologies do you need to implement industrial symbiosis, are very clearly related to CO2 capture, storage, reconditioning, electrification of processes, large-scale electrolyzers, for example, process technologies, methanol and hydrogen, purification technologies for waste, and biotechnology for the use of renewable resources. In order to foster Europe's development towards CO2 neutrality and circular economy, we recommend that R&I investments are clearly increased. And that would be from the private side, but also through public funding. And beyond that, I think investments in pilot and testing facilities is crucial, because decision makers need to be convinced that these installations will actually work when they invest the money. And we also recommend to establish a community of practice. Maybe we have some time in the discussion later, but the common knowledge of installations about each other is probably not at the level where you would want it to really have the biggest impact. And there are some good ideas about what this community of practice could do. I'm going to skip them now, and maybe we can talk about it in the discussion. And another point that's probably relating to what you are going to say is data and information exchange is absolutely necessary to identify the potential that industrial symbiosis could have. So a proper installation of databases and IT infrastructure, I think, is one important aspect, and maybe tools like artificial intelligence can help in making this endeavor neutral. Also, it's recommended to use the hubs for circularity that Spire is proposing. I've heard a lot of good comments, and that came also out of the discussion that we had in the workshop. It seems to be a good idea, a good vehicle to promote industrial symbiosis. So Pierre Joris will talk about it, and I'm sure it's going to be interesting. The aspects of industrial symbiosis should also be included in education. If engineers and business people are meant to implement these new concepts, they need to learn it at the university. So it's a good idea to include that in the curriculum. And facilitation is hugely important. I can't repeat that often enough. To make sure that you come from a vague idea to something that actually works is huge. So in summary, you can see we addressed a lot of topics in this study. Research and innovation investments are absolutely needed. I could give you quotes of practitioners who say, I need these technologies so that we have them available for the quantities. You can run things with existing technology, but to make them work in an efficient way really needs these investments, and it's not just technologies, it's methods and tools, and I think it's also pilot and demonstration facilities. And I think if we do all that, then we have a good chance to create the benefit commercially for the competitiveness of the companies, ecologically, obviously the way we all addressed it already, and then ultimately for society. So thank you very much. That's the short summary of what we've done so far, and then I'm looking forward to the discussion and your questions. Thank you.
Well, Dr. Zummer, thank you very much. I was very interested to hear about your symbiosis readiness level. We have a lot of food for thought also from your study and your presentation. The colleagues have noted them down, but the role of industry and industrial symbiosis in achieving our targets, the need for more research and innovation funding in this area, the need to invest in pilot and testing facilities, the communities of practice, the university curricula, all of that is something we really have to take into consideration. So now we move to our panel, and the first one I would like to ask a question to is Rachel Lombardi from International Synergies. So Rachel, you've been dealing with industrial symbiosis for quite some time already in both your academic life, I would say, and also from an industrial perspective. Could you give us perhaps a few examples so that we can measure what kind of impact industrial symbiosis and those projects can have on reducing waste, on lowering emissions, etc.?
Thank you. Yeah, so international synergies very much comes at industrial symbiosis from a practical implementation standpoint. We have enabled industrial symbiosis now in 35 countries, touching every continent and crossing economies and cultures. So the idea is not new, as we said, as EU delegates last week in Mexico, ask your grandparents. This idea has been around forever. We didn't used to be as wasteful as we are now. So I encourage Horizon Europe to very much build on this existing experience and building on the global experience. And their challenge, I think, from the co-creation standpoint, will be developing a coherent funding approach across the instruments that focuses on impact and builds on the global progress. I support the call for investment, research and innovation investment in specific technologies, focusing on the demand-led needs that industry identifies. So if we have a material stream that has a contaminant that we need to prove we can remove the contaminant and produce a reuse material stream that is suitable, that is safe, that is proven for industry to be comfortable to uptake this change, that's an important place for investment. Some of my examples Klaus has already provided. Just one small correction. The ShareBox figures, which were correct, were not per year, but they were already delivered. This is not a theoretical assessment of what could be potential. These are projects that industrial symbiosis projects identified and facilitated through the ShareBox project on Horizon 2020 Spire. And these results have been already validated. Additional revenue of 54 million euro, not per year, unfortunately. I'd love to say it was. Cost savings of 14 million euro, carbon reduction of 1.4 million ton equivalent, and 74 jobs created. NISP England was another example that he's provided, largely already given the figures, but let me clarify one of them. 42 million tons of carbon equivalent avoided at a cost of less than €1 per ton. So we have already the methodology that we know how to deliver carbon reduction for less than €1 per ton through facilitated industrial symbiosis. The industrial symbiosis service in Northern Ireland has been going now for, I think, 12 years. Delivered 16 million pounds of revenue, 26 million cost savings, 352,000 tons of CO2 equivalent, and 100 jobs. So again, this practice is real, frontline, actually happening now. Yeah. So let's build the research on the practice to advance that practice. Now, where do we need that? Facilitation is absolutely necessary for the foreseeable future, as in general, 80% of your opportunities are outside your own sector. Not true for every sector, but the majority of sectors, okay? So as long as bakers are learning baking and not pharmaceutical extraction of proteins from collagen and eggshells or whatever, then they're never going to be able to identify the opportunities in pharmaceutical applications of their eggshells, right? And we shouldn't expect them to, even with the best training in the world. And 20 years ago when I was teaching this stuff at Yale, the classroom was full of engineers and environmentalists and business people in the same class at the master's level so that they could understand this from a holistic perspective, so going to the training needs that Klaus also identified. Our ICT Our International Synergies ICT hosts data from over 33,000 sites on almost 100,000 resources. Data sharing is not an intrinsic barrier, but it has to be handled appropriately. Like making a souffle, it has to be done appropriately. You can't sort of go at it, blind with a bat, okay? It's got to be done right, but it can be done because it's being done. This is the voice of the practice. Poorly aligned business drivers are a barrier. So trying to translate a technically proven business case solution from one country in the Union to another country where the basic drivers are different, the landfill tax is different, the landfill ban is different, the translation of the waste framework is different, the same solution does not get replicated because the business drivers are not the same. So looking at those business drivers, the targets, the complex regulations, we need a constructive, supportive policy environment that is as uniform for business as possible for maximum replication across Europe. So industrial symbiosis is not yet zero waste, zero emissions, but we are progress, real impacts, quantified, validated, audited, LCA'd, evidenced impacts today. So we know how to do this. We need to find ways to get the Commission's different parts to work together to foster, to advance this implementation. The DG GROW project, which will be announced hopefully very soon, that was bid for last year to establish a pan-European network, will be part of that. We look forward to that project. The Erasmus Blueprint for Vocational Educational Training is another part of that, and we look forward to that project as well.
Rachel, thank you very much. I think you underlined very clearly that practice shows that the impact is measurable of industrial symbiosis, that this impact could be huge, and we have to do more. I took note of your call for a coherent funding approach. Maybe we can talk a bit more about that later on. And now let me go to Pierre Joris. You're the current president of Spire. Maybe you can tell us a little bit more about the public-private partnership and about what you think are the main achievements that you have been able to reach during the past few years, as well as the road ahead.
Okay. Thank you. And first of all, thank you for having me here. I would be tempted to talk about the practical achievement like you did, because there have been many projects. It would be unfair to choose one of those projects, but I'd like rather to highlight more high-level achievements. And first of all, and I think for me it's the most important, is since Spire has been created, is really the cross-sectorial collaboration that we have been able to foster, which seems to be granted today, but I can tell you was not at all granted 7 years ago, and it's been really unprecedented. And today we have all our 8 sectors, from steel, cement, chemical, non-ferrous. I won't cite them all, but they are really working, collaborating, exchanging information on a regular basis. And to me, that's the first biggest achievement, which is general one, but for when it comes to circular economy, that's really key. A second achievement, I think, is the fact that we have really put circular economy with Inspire on the radar screen of all our members. When we started Spire, it was resource efficiency. Of course, circular economy was part of it, but the focus was not circular economy. And with time, when I look behind now, I can see that within Spire, we have spent 200 million euro out of a total budget so far of 500 million euro on projects that relate to circular economy. Within those, we have really 7 projects clearly specific to industrial symbiosis that have helped us really deliver interesting technology to improve the cross coordination between sectors, to put tools in place, etc. So all this has really increased very much the level of awareness of all our members and all our associations, so that I think for the next cycle, this becomes really a key point. And the third achievement, I think also probably one of the most important, is the way that we have been able to learn and to build on the learning of the different projects, because precisely of the partnership structure. Because we have that partnership, because we analyze the calls, we have been organizing workshops, we are really able to learn from what has been delivered to build the next roadmap. And today we are really defining completely new innovation ambitions in this area. And that brings me to the next step, by the way. But for example, there is a call in 2020 which is focused on industrial symbiosis that will not replicate at all the previous call, which sometimes happen, you know, when you don't have that coherence. We have really come to the realization that process industries are key to also solve the waste issues because of the capacity of this process industry to absorb very huge quantities of basic materials. So we have now a new ambition for, you know, a next vision of really reaching this zero landfill and have a role in not only industrial symbiosis, but also industrial urban symbiosis. And we have come up with this new concept of full circularity. But so that brings me to the next steps. And before I talk about hub for circularity, I would like to insist once again that to me, one of the major steps for Horizon Europe is again a very strong financial support. I mean, we still and I think Klaus mentioned it, we still need a lot of research innovation within this field. There is still a lot of technologies that needs to be brought to a certain maturity level, very complicated one. And there are ambitious objectives, which has been reminded, and also by our newly elected president of the Commission. And it is certainly not the time to decrease the efforts. I mean, continuing in a business as usual way is not an option. We have to have disruptive efforts, and so really our association signed this strong statement that we really support this 120 billion euro budget that has been proposed, and it's not the time to decrease it, otherwise we will fall behind our competitors, I would say globally, behind US, I'm sorry that I know you are US origin, Chinese, you name it. So really strong financial commitment is needed. We are not in favor of capping the resources for partnership, which we think are the best way to accelerate innovation in the industry. That's one point. And the second really important next step that we see is precisely these hubs for circularity. Now, what we have in mind with hubs for circularity is really, how to say, a key hub where you have connection between industrial sites and public sites. Defined geographical location because we think that's needed, and with really a common and collective purpose of improving substantially the circular economy, the decarbonization, and also very important to boost the competitiveness of the industry. Now, these hubs, we are really convinced that with the ambitious objective we have of zero waste to landfill in 2050, with a low carbon or carbon neutral economy by 2050, there is no other way. I mean, we have really to, it is through these hubs that we will achieve these ambitious objectives. A single plant isolated will not be able to do it. So we put a lot of emphasis on this. There's a lot of people excited about the idea across the different regions, but it will not happen by itself. So we have heard about facilitation. There is a lot of hurdles to go by. And so we think there is a role for Horizon Europe to play there. Of course, the hubs will be implemented locally. There will be a need for regional funds, but we are convinced and we are really advocating for a clear, a clear place within the Horizon Europe arsenal to support this hub for circularity. I think we need financial support to help overcome the first hurdles, to finance the facilitation. There will be a need for Horizon Europe and our future partnership to define exactly what are the criteria that this hub for circularity needs to satisfy, and there will be a strong need to cross-fertilize and to make sure everybody is aware of what is happening in other regions, other countries. So fostering this cross-fertilization and coordination is very important, and we think this is our role also that we can handle to this new partnership. So I will stop there because I think we are also running out of time, but we can certainly discuss further about this.
Well, thank you very much, Pierre. I think you have mentioned two things that are key to the success of industrial symbiosis. One is cross-sectoriality, and the other one is broad partnerships that go actually beyond industry in order to be successful. And of course, I take note of your strong call for support, including through Horizon, for hubs for circularity. And that is a perfect transition because Kalundborg, in a sense, is a precursor. It's a kind of hub for circularity. It's a well-known example of industrial symbiosis. So perhaps, Lisbeth, you can share with us a little bit how this hub, how this experience has affected positively the competitiveness of the participating companies, how it has also affected and improved their sustainability, and what are the lessons that you draw from this experience?
Definitely, and thank you very much for having me here. It's an absolute honor to be invited into this co-creation process of the new program of the Horizon program. We've been existing in Kalundborg as a public-private partnership since 1972. I think the first project was running there between the refinery and Dubreuil, but starting with a public-private partnership on surface water way back in 1961. So we've been in the area of working together for a very, very long time. Not only creating a value for the companies involved, but also very much for the local community in Kalundborg. I will give you one example that created value in a circular sense. And this is the building of the new biogas plant using the fermentation slurry from Novo Nordisk producing insulin in Kalundborg and Novozymes producing industrial enzymes. And they take this slurry, this waste really, upgrading it to natural gas, preserving valuable components such as phosphorus. And the capacity is 8 million cubic meter of biogas a year, equalizing the energy consumption of approximately 5,000 private houses. So that's quite a big plant running in Kalundborg now, being built by private funding and with the symbiotic mindset, really. I've been doing this kind of example together with Klaus, running it through the symbiosis readiness barometer, and I think that has been a very eye-opening process for me, taking in consideration that as a facilitator we are only joining these kind of processes in step 1, 2 and 3, mapping the local resources and the streams, getting the partners to talk to each other, introducing them or reminding them about the symbiotic mindset and common inheritance that we have in Kalundborg, and then we're sort of letting go of the process, leaving it to the companies for them to design the technology and the actual plans of the unity, and then again picking it up. Sort of reimbursing the story of symbiosis, sort of collecting the knowledge and the experiences from the project, and building on top of that when we are doing the next industrial symbiosis project. And I think it's very important. The barometer, it teaches us important lessons of the role of the facilitator of symbiosis, and I think that is something that we need to elaborate on. I am looking very much forward to the workshop in November, where we're going to sort of unfold this very practical and specific case of industrial symbiosis. I think the mapping of existing resources available in the area is very crucial for us to implement more industrial symbiosis projects, but also the management side of the allowance for people working in the plants to think outside the fence of their own premises is very important. So I support very much education and cross-sectoral approach to these projects. In Kalundborg, we think it's very important also to support SMEs and startups as well as students, for them to be invited into these potentials that can only be elaborated the more partners that we invite to work with us. Also, I think it's very important for us that we can actually document the benefits in numbers on what we're doing. Not only saying that we're doing good for the world and saving the environmental impact, but also actually to point out how much is that in numbers. And we did a life cycle assessment back in 2015, saying that we'll save 635,000 tons of CO2 when we have the full transition of the power plant by the end of this year. So that's something, and for me it's a proof that industrial symbiosis does actually make a difference. It does create a more sustainable approach to production.
Thank you.
We have a new strategy for Kalundborg symbiosis because we don't want to rest on the laurels and look back in history, sort of clapping each other's backs, saying how good they were back in the good old days. But we want to improve and make even more new products in the future, and we need sort of people to help us to bring in new knowledge and new money to the area, and to facilitate test and demonstration as a way to achieve the very ambitious goals that the companies and the local government put for themselves in the future. So before 2025, we'll make at least 10 new streams in Kalundborg symbiosis. So please help us.
Thank you.
Do that.
Message received.
Yeah.
Thank you very much.
Yeah.
No, that's of course an impressive showcase. You were asking about testing and prototyping, but that's a real case that shows that it can work. It illustrates also the importance of the facilitator. And now we move to Valentina Kolla. Your research activity deals with simulation, modeling, control of industrial processes. So what role do you see for new technology, artificial intelligence, etc., to develop and facilitate industrial symbiosis?
So thank you, and thank you for inviting me. I think that the new digital technologies and the advances tools that you mentioned are an enabler for industrial symbiosis. Just to explain you how, I will make very rough examples, of maybe too didactical for some of you, but I think in industrial symbiosis, what we have, and you have some streams of materials, streams of energy, water, and altogether water and energy, and so on, that come out from one sources and can be shared, can be input, can fed other processes, and in order to do this successfully, you need to characterize these streams. That means measuring, for instance, their physical, chemical properties, and not in an average way, because if you are feeding an industrial process, this process is affected by the point-wise values, not by the average ones. So you have to measure all the properties in an accurate way and continuously with sensors and appropriate measuring techniques, or soft sensors when you need to do this indirectly. And this generates a huge volumes of data which are heterogeneous, non-structured. They can, in some cases, meet the definition, academic definition of big data. And all these information need to be transferred in a secure, efficient way between the sources of one process to the potentially receiving ones, or to the stakeholders, need to be elaborated, need also to be stored and processes checked, and then the relevant information need to be extracted, in let's say efficient way to be presented to those who can exploit the streams, to verify and to let's say to verify where the quality of the stream is suitable. And in this sense, machine learning, artificial intelligence, for instance, are very powerful. But not only, because if you are presenting this to a human actor, you need to do this in an ergonomic way. So that means showing the relevant information with means like augmented reality, like let's say, advanced human-machine interface. And then you can go beyond. You can say, okay, with this huge volume of data that I have, I can extract, I can improve my forecasting capability. I can try and detect in advance whether there are anomalous conditions, whether there are events that are relevant for the usage of these streams. Again, here, machine learning, artificial intelligence can be a powerful support. And also, you can connect this kind of elaboration of information to the control of some of the system of the processes that are fed. Again, by elaborating this information, you can try to optimize the distribution of the stream. So in order to maximize the profitability, the usage, and optimize based on the features of these streams. And again, advanced optimization techniques, bio-inspired, also bio-inspired, can be of help and can develop efficient decision support tools. I heard the previous speaker talking about decision support tools. This is also a relevant when you talk about cognitive plants. What is a cognitive plant? It's a plant that has models which are fed by which are, let's say, evolve, exploiting the data, that are capable to self-learn from the data, and which are capable to self-adapt and improve the flexibility, the reactivity of the plant with respect to changing operating conditions, variable production process, and so on. In this sense, the self-adapting capabilities of machine learning for modeling and simulation, in this sense, they can be very profitable. And one aspect that needs to be also highlighted is that these tools that helps to process information, to elaborate information and present, these are a strong support for human decision. When you talk about artificial intelligence or machine learning, you need to think that this is not a replacement of human intelligence. It's a way to let human focus and take the time for good decision, to support the human decision, to help humans to elaborate an enormous variety of information which is no more handleable with normal means. So human is still in the loop when you talk about artificial intelligence of machine learning, which are techniques which are used to take better decision, more informed decision, more rapid decision.
Valentina, thank you very much for your insights on the role of technology. Let me move directly to the questions, because there are some questions. Well, I guess the second one is quite straightforward. Where can we get your report, Dr. Zummer? You're available here, and you will give the coordinates. Are economics in industrial symbiosis sufficiently attractive for systemic change, or are regulatory and economic policy measures necessary to induce adequate research and innovation? So beyond funding that we've been talking a lot about, do we need to have some regulatory policy measures? Who wants to intervene? Yes?
Well, first of all, it's difficult to answer in the whole generality, because one case can be very economically attractive, another one can be more borderline. So when it comes to the economic viability, I couldn't make a general statement. But where we need regulatory environment, it's not so much in helping the implementation, it's more on the regulatory itself. For example, how can we manage waste as a raw material? I mean, there is a whole slate of adaptation to the regulatory environment that will be needed so that this type of waste usage can be facilitated. So that's one of the examples that comes in my mind. Now, on the economical side, generally speaking, because we are dealing with completely new technologies, it's true that until you reach a certain scales, very often you will not be competitive. So I think in most of the case, you will need to have regulation that will help either create a market for a certain product or that will alleviate the cost of the implementation until it gets to scale. So that would be my comment. I don't know if anybody else.
Maybe I can add. The answer, like anything with sustainability from our practical experience side, is it depends. So we've never had a program in 35 countries that has not delivered completed industrial symbiosis projects. But we have had proven technologies fail to transfer, fail to replicate from one country to another country because the economics don't stack up in the second country. So if it's a big cost for landfill in the UK, but very low or no cost in another country, then the business driver does not exist, which is why I identified those business drivers. The regulatory consistency would be a wonderful thing, but I don't know how much more clarity can be available at the Commission level because the member states still have their rights to adapt as they see fit.
Any other questions from the floor? We will soon be coming to the end of the session, so that's your last chance. Yes? A mic is coming your way.
Oh, hello, my name is Alex. I'm representing ERDF-funded large research program called Flagship. And the question is, who should be a data holder? Because we work with companies, and we reach the point that we would like to model a smart energy system. But there is a big issue about sharing the data. Who should actually hold the data, then model the data? I know that we have a modeling capacity as a university, but at the industrial level, when you have an industrial symbiosis hub, what is your experience, your advice on that?
Well, very good question, because this is a key factor indeed, as we heard.
Can I?
I think it's a very good question because we have experienced that there's quite a big sensitivity for the companies involved about the data that they are giving out for instance, for an LCA analysis. So I think that's something that should be worked with and uncovered. But perhaps if you have a neutral facilitator, an industrial cluster, they can manage the data. But definitely, that should be worked on, because if we don't figure out who's owing the data and to what extent do we have these open data sources, then we will never succeed in doing these projects.
Look, I started facilitating industrial symbiosis as an academic. I now do it from the private sector. It's a completely different experience. Companies will share amongst private sector because that is how they do business, right? You have to tell people what kind of paper you want for your copier to buy paper. It's that simple, right? So the idea of open data, making my information available to anybody, was always going to make me nervous. But the facilitator, I agree with Lisbeth, and again, our experience from South Africa to China. Okay, China's a bad example because they gave us the regulator as a partner, so that was just disaster. But the other parts of China that we did, to Finland, that independent facilitator, who is not the regulator, will be given access to the information that it is in the company's interest to provide. But the conditions of that information need to be spelled out in advance. Now, we had in NISP, with 12,000 companies, a confidentiality charter available. It was signed once in 8 years with 12,000 companies. Once. That's why when people say, oh, data, it's just not our experience. As long as it's handled appropriately, and appropriately changes region to region, from South Africa to Finland to wherever.
Yes, there are more questions from the room, but I'm afraid that since we are web streamed, the connection will be cut at 6:10 precisely, so we have to come to the end. You can come to speak directly to the panelists afterwards. Thank you very much, dear panelists and dear audience. It was a very rich exchange. I think we got a lot of food for thought and substance to develop our strategic programming. We are convinced that research and innovation is key to develop industrial symbiosis. We need more funding for it. We need also to go to the next generation, I would say, in industrial symbiosis, and to go for these hubs for circularity. Partnerships are also something that we have to look at. This is crucial, and maybe to close, I would come back to what I said at the beginning. We have just launched a call for proposal, which is cross-cutting, which addresses several strands that are very relevant for industrial symbiosis. It's about 200 million euro, and 100 million euro is for industrial symbiosis. So don't hesitate to contact me or our colleagues from the EASME agency to know more about that. It's ongoing. You still have time to prepare your proposals. Thank you very much, and have a good evening to all of you.